of our knowledge, by virtue of what we learned last week, the extent of our knowledge on number base, and having the mind that our timing is restricted to 40 minutes of a class, so we have just 35 minutes or thereabout left. So having believed that you have learned some important things about number bases, basically, moving from one base to another, basically within the range of base 2 and base 10. So we are not just going to waste our time. And I just want to use this medium to talk about a bit of it, which might likely be given. And that is conversion of number base in decimals. It's possible that this time around, JAM may want to go that far. Yes, and I mean that far. But so far, so good. We have learned about when you have a number base that can translate into equations of different types: addition, subtraction, multiplication, division of number base, that it is not always that straightforward. It is very confusing. So I will always encourage students that if you want to divide number base, the best thing to do is convert those values to base 10 standard. Divide your number in base 10, then convert it back to the required number base. Because most times there may be questions that will be as terrible as a number in base 8 to be divided by a number in base 5. And please be noting this, every discussion here is very crucial. They are packed with a lot of information that you need to take to the exam hall. And I will give you some strategy today. It's not just going to be working of mathematics. There is the strategic aspect of it that you need to be aware of. All right. There's still a lot of question around whether JAM marks negative marking or not. Because when you are given 40 questions, 50 questions, and you are seeing 41, you are seeing 77, you'll be wondering what is happening. Okay. One of the things that happens is JAM questions are not always of the same value. There are some questions that are 1 marks. There are some questions that are 2 marks. All right. So the weight of every question depends on their difficulty in a way. So it's not that they do negative marking. That one has been confirmed that JAMB doesn't do negative marking. But they won't come out. They have never come out to tell you this is how our marking system is like. All right. So it's not that I found out, by experience and by different other testimony. When students write JAMB, it is not that they do negative marking. It is what you get, they give you. But the only difference is that the questions don't carry the same weight in marking. Some are 1 mark, some are 2 marks, some are 3 marks, highest, depending on the weight of that question. All right. So that being said, take note of that. All right. So the next thing you should know is that JAMB will give you 4 multiple choice answers to each of the questions they give you: A, B, C, D. A, B, C, D, 4 multiple choice. What that means is that you only have 20% chance of passing. 20% chance. For every question, you are only 20% certain, if you gamble, that you'll be correct. So you have higher chances of failing than passing. That's why you see more people failing JAMB. It's not everybody that prepares for JAMB. And even if people prepare, there is a strategic way of preparing that people don't take to it. It's not about just, a lot of very brilliant students fail JAMB. They know this thing, but they fail JAMB. What happened? The strategy aspect of it is not being taken into consideration. Students waste time on 1 question. All right? Students waste time on 1 question. They will just continue to solve, and you'll be wondering what's going on. What's going on, Before you know it, time has gone. And you need to be very, very strategic. When the question is wasting your time, please just quickly drop it and move away. So all those things are the necessary aspect of it that you need to be armed with. Okay. So now we are going to do a bit of some questioning. I want to give you some questions to work with. I have a past question pack with me here. It is not in soft copy. I would have loved to be sharing through the interface, but it's in hard copy. So I'll do my best to only dictate questions, and the ones that I can write, I will try and type it so that you can note it. But we have actually extensively, discussed the basics last week. So I just want to give you questions to try on your own, so that at least whichever one you did not get right, then we can still come back to it and work on it. So let me go to the section that has the binary or binary numbers. So I can pick another one because I have several of it. Okay, I think I have one here on this page. So I'm just going to put some questions up now, and then I'm going to type them so that everybody can see them. Just a moment. We get the exact page here. Okay. Please, I will need, is the sharing enabled, sir? Let me try. I think it is. Okay, good. Good. Thank you. All right, so I want to write a question up now. Look at this question. There's an equation we are asked to solve for x in this equation, and it is all in base 2. 11 over x is equal to 1000. Everything is in base 2, all over x plus 100. All right. 11 over x is equal to 1000 all over x plus 100. So in this case, every number, including x itself, is in base 2. So you are asked to solve for the value of x. This is question number 1. I call it practice question. All right. I think you'll find it in 1985 JAM. If you have past question with you, I may not tell which particular number, but you will see it in 1985 JAM. Okay. Then this one now, y is equal to 23 base 5, 23 base 5 plus 101 base 3, 101 base 3. And then you are asked to find the value of y in base 2. Find y in base 2. In base 2. Base 2. Find y in base 2. These are practice questions. This one can be found in the 2018 question pack, year 2018. Just like I said earlier, I don't know which number, they started, what do you call it now? Question types. So most of those questions, the one you see in question 2 in one pack, maybe in question 48 in another pack. But definitely you will see it in the 2018 question pack, that number 2 question. Let me also check. I really don't want to pick the commonly simple one. There is a lot of it. Okay, then there is something I noticed last week. We solved the question. The answer we got was correct, actually, but it was not a practicable answer. Please note, not a practicable answer. It was correct, but was not practicable. I couldn't really lay my hand on that question again, but it was when I finished, I discovered that it was the correct answer, but it wasn't a practicable answer. I think it was supposed to be a number in a particular base, but the value that we got was higher than the base itself. All right. So, and JAMP set that question. It was JAMP that set it. So, but it wasn't practicable anyway. That was my observation for last week. So in case you have the solution and you are wondering, could this be true? The correct answer is yes, it is true, though it is not practicable. So just keep that. Okay, I just want to add one more question and then I'll move away from there. X in base 10, this one is a simple one actually. I just, is equal to 23 base 5. So you have to find X. Oh, sorry. 23 base 5 to find X. All right, so you can just walk around these 3 questions as a follow-up to what we did the last time. So I actually wanted to talk about when you want to convert decimals. Let me see if I can do all that in 15 minutes, then we can move to another topic under the remaining 15 minutes. By 6, did I say 15 minutes? In the next 20 minutes, we should be rounding up because of time. All right, so if you need to access this, I can go back to it. Now, if you are given a number like 1101.11 in base 2, and you are asked to convert this to base 10, please, I need you to learn very well to convert this to base 10. What you need to do is that, just like we expanded last week, we are going to consider 2 parts now. We have what I call the whole number parts, which are underlined in red. And when we have what we call the decimal part, underlined with blue. So I'm going to do my expansion based on these 2, and you are going to get something. So 1 times 2, don't forget we are converting this to base 10, to base 10, to base 10. Let me just use capital letter B for base, then use 10. All right, to base 10. So 1 times 2 plus 1 times 2 plus 0 times 2 plus 1 times 2. These are the ones underlined under the red, the whole number part. So I'm going to have 0, 1, the powers now will change, 2, then 3. This, I will still underline it with red to show that the expansion underlined in red is what I have here. Then I can put a decimal point here. Then I will now continue with that expansion I've been doing, but this time around, I'm moving to the decimal part. So it's going to be 1 times 2 plus 1 times 2. But this time around, you can see the trend of the powers of 2 is coming down from 3 to 2 to 1 to 0. And what do you expect? Just like the normal number line, this one will carry -1, and then this one will carry -2. That is how the expansion for decimal part will look like. The first one will carry -1, the second one will carry -2. Please, I need you to note when it is the decimal part. So I'm going to underline that with blue. All right. So you can now see the trend now that flows, just like from the last number, -2, -1, 0, 1, 2, 3. Yes, that is how it should be expanded. Converting from other bases to base 10. This works for every basis to base 10. When you are converting from other bases to base 10, and it has to be decimal points. Okay, so I'm going to quickly work on it. 2 raised to power 3 is 8. So 8 times 1 will give me 8. I'm doing some compression now because of time. Plus 2 raised to power 2 is 4. 4 times 1 is 4. And at any point you are not getting this explanation, you are free to talk. Just unmute your mic and talk, or possibly you can raise your hand. If I can't see, the host will see your hands up and will call my attention to your hand, so I can quickly attend to your doubt. Then the next one, 2 times 1, 2 raised to power 1 rather, is 2. Anything raised to power 1 is that number. So that would be 2 raised to power 1 is 2, then 2 times 1 is 2. So I'll retain the 2. Then the last part of the whole numbers, 2 raised to power 0 is 1, and 1 times 1 will give me 1. So I can add all of that. These are the red line. You can see the way I'm solving in part. But please, don't make a mistake of solving differently in terms of, I'm solving in part, but I'm not removing it separately. I'm not separating it, yes. Because some students will go and solve the whole number part somewhere, solve the decimal part somewhere. And thank God, well, in a way, if you are good with what you are doing and you can track it, fine, because it is not a theory question. But it does matter. Your steps really matter. If you are following the wrong steps, you are not expected to get the right answer, by default, or by, I don't know, by means of luck or anyhow. You might, but then it's always better to be sure of what you are doing. So I want to continue. I'm still continuing this line, but now I've switched to the decimal part. 2 raised to power minus 1. By the rule of indices, and I'm going to erase this, I just want to quickly put it up. A raised to power minus B is the same thing as 1 over A raised to power B. This is a rule in indices. We are going to talk about it in one of our classes. I just want to clear everything based and whatever. Then I will give you in the next 15 minutes now, because I'm tracking the time. I'm going to give you some tips about percentage decrease, percent. I will rush over it. If you have any question, bring it to class. We can solve it here. All right? Because most of the questions that has to do with percentages, they will actually want to include it in other questions. That's how they do it. So it's not that the question will come under percentage or something separately. You might not have it. The total number of questions for mathematics is 50. And they have all the list of topics to cover. So there's a way they nest it. A question they are asking you contain about 3 different topics. All right. Last week, we talked about number base that led to quadratic equation. So it happens that way. So you may not even see quadratic equation at all throughout the question, but in one of the questions where you need to solve, you just see it hanging in there. So you need to learn that. Okay, so I'm taking this away because I just need to use that knowledge to solve the decimal part. So what I will now have is 1 times, it's not picking my distance already. Okay, so I'm having 1 times 1 over 2 raised to power 1, okay? Then plus 1 times 1 over 2 raised to power 2 by the rule of indices. A plus 4 plus 2 plus 1 will give me 15. So I have 15 points. Then I can do 1 times 1 over 2 plus 1 times 1 over 4. So at the end of the day, I'm going to have 15. You can see I'm taking everything together in one line so that I will not lose the track. 1 over 2 times 1 is still going to give you 1 over 2, plus 1 over 4 times 1 is still going to give me 1 over 4. So I can do the addition of these simple fractions. Most times they don't give fractions separately too. And once they give, there are some fractions that they give. We are going to talk about that. Those fractions are very interesting fractions. So the LCM of 2 and 4 is 4, of course. How many 2 are we going to see in 4 is just 2. 2 times 1 will give you 2 plus 1. So what you have is 15 whole number 3 over 4. I'm going to put that on a new slide. 15 whole number 3 over 4. So we are going to have 15.3 over 4, which is the same thing as if you do the calculator division. You don't need calculator because the calculator, there was a day they gave, there was a year they gave calculator. I don't know whether they still do, but then these are what you can do. You can just write it as 15.75. 0.75 is 3 over 4. So 15.75 is in base 10. So this is what you have, 15.75 in base 10. And that's what you have there. So we have converted 1101.11. So I can write it therefore 1101.11 will now be equal to 15 in base 2 anyway, is equal to 15.75 in base 10. Please note that it is not that you cannot write it as 15 whole number 3 over 4 in case they ask you to write it in fraction. 15 whole number 3 over 4. These two answers are the same, but it now depends on which option they are giving you. If they are giving you the option of writing 15 whole number 3 over 4 that is in fraction, fine. It's the same thing as 15.75. So please note that. Then the converse. If they ask you the same thing, but this time around, you need to be more technical, and then I need you to understand this perfectly. We want to convert from base 10 to other base. This is how it applies for every base. The only difference is that because we are converting from base 2 to base 10, because we are converting from base 2 to base 10, each of the number given here, we are using 2 to multiply it, the powers of 2 to multiply it. If it were to be from base 3, we are going to be multiplying it with powers of 3. If it were to be from base 4 to base 10, we are going to be multiplying it with powers of 4. That is just that. So I don't want to repeat, okay, I can. It is not a bad idea. So I want to now check, what if you are given a number the other way, from base 10 to other base now? Like convert. So this one is closed. We are done with this. That's our final answer. We are okay. So another one is to convert. Let me use a number like 27 point, which one, 625, to a number in maybe base 5. Let's see. This is 27.62. No, we can't have it in base 5. This is in base 10, definitely. So to base 5, to a number, please just note the procedure is the same thing, to a number in base 5. And I'm going to solve this in the next 4 minutes. Let me see if I can, with all the explanation and everything, in base 5. Please write down this because I'm going to the next slide. 27.625 is in base 10. Now we want to convert to any other base. It can be in base 2, it can be in any other one, but we are interested in the same procedure will work if we are going back to base 5, but we are not going to repeat this same thing. There is another aspect we are going to explore in that one. So 27.625 base 10 to a number in base 5. Let's quickly go for that. So what I'm going to do is that I'm going to write 27.625 is in base 10. And of course, you can see that this one also has what I call the whole number part and then the decimal part. So I'm going to, this time around, I'm going to separate. The usual way of converting from base 10 to other base is that for 27, the whole number part, you write it out like this. You write 5 here. Then you are going to now write this one. 5 in 27 is 5, and there's a remainder of 2. 5 in 5 is 1. There's a remainder of 0. And then 5 in 1 is 0 with remainder of 1. So I'm writing this part, and that is 102 in base 5. Then the decimal part now, the decimal part, which is underlined blue. So I'm going to write 0.625. And then I'm going to continuously multiply this number by 5. So times 5. And look at what will happen. 5 times 5 is 25. 5 times 2 is 10. 10 plus 2, that's 12. I'll put 2 here. 5 times 6 is 30. Plus 1, that's 31. So I'm going to put 1 here, and I'm going to write 3 here. Now, the first answer I got, I'm going to note it. Let me use green. I will underline it. This, after the decimal points, these are the numbers I'll be writing down. Then I'll go back. I'll multiply the number before the decimal part by 5. 5 times 5 will give me 25. 5 times 2 is 10. 10 plus 2 is 4. Then that's 14. 10 plus, that was 25. I will write 2 on the other side. Then 5 times 2 is 10. So 10 plus 2 is 12. I'm actually supposed to say 12. So I'll write 2. Then I'll carry 1. 5 times 1 is 5. Plus 1, that will be 6. So there's nothing to multiply. You don't multiply the number you are picking already. You just put 0 there. Then you continue to multiply by 5. It's okay when you have about 3 decimal points, because this number may not exhaust. So you still multiply by 5 again, and we go. 5 times 5 is still 25. 5 times 2 is 10 this time around, plus 2, that is 12. You write your 12, you carry 1. 5 times 6 again, you are going to have 30. Then 30 plus 1, that's 31. So we can see that it is a repeating number, 303030. That's what we'll continue to get. So now we underline all these numbers, and those are the numbers we are going to write down, just like we have. So it's going to be 102.303 base 5. So We are going to have 102. Let me use the previous one I've been using, the previous color. So it will now be 102.303 base 5. So just like I demonstrated, so you can use the previous method to convert from base 5 to base 10. You will see that you will get the same answer that we got earlier, like the answer we converted back to base 5. So we have all of this. If you want to check whether your answer is true, you can check. Of course, 102 base 5 converted to base 10 will give you 27, and 0.303, you can also try it. 3 times 5 raised to power minus 1 plus 0 times 5 raised to power minus 2 times 3 times 5 raised to power minus 3. That is if you are taking it to base 10. Okay, so I think with that, we have something good to work on and as an additional knowledge that we are gaining. All right. So I can effectively say from the previous slide that 27.625 base 10 will now give us the answer we arrived at, which is, let me pick it out, which is 27 points. Therefore, we can just safely conclude that 27.625 in base 10 is what will now give us 102.303 in base 5. All right. So your assignment is, you can now decide to convert 102.303 in base 5, convert it to base 10 using the first method. And then using the second method, go to what we have done earlier, convert that one back to base 2, and let us see whether we are going to have the same answer that we have. So just try both. Okay, so I'm calling it an assignment for you. So 303 base 5, you are going to convert this to base 10. Convert it to a number in base 10. That's the first one. Then let me go and pick the first question we solved. I think we concluded on it. So you convert 15.75 base 10 to a number in base 2. Let's see whether we are going to have this same answer. So you have your answers in mind, then employ the appropriate method and see whether you are going to get. So 15.75 from base 10, convert it back to base 2. Okay. You have to convert 15.75 so we have this. Just note this. This is a very good assignment for us. Or you can call it homework or practice question, anyhow. So for this first question, you will use the second method. And for this second question, you will use the second method. Let me come again. We are converting from base 5 to base 10. So you will have to use the first method I used, follow the way I solved the first example. And then for the second question, you will need to follow the second example I used to get your number to base 2. So you are going to convert the number, whole number parts, and then you part. And because you are converting this to base 2, it is 2 that we use to multiply. When we were converting to base 5, we use 5 to multiply the decimal part. So if you are converting to base 2 now, the decimal part must be multiplied by 2 repeatedly until you exhaust it. So don't forget that. All right. So I'm going to hand it there for number base by God's grace, believing that we have explored all the necessary aspects that we need to know. So the next is, if you come to class, come with question. If you are on the WhatsApp, let us discuss. That's 4 minutes. So yeah, 3 to 4 minutes. Let us discuss percentage increase, percentage decrease, and all the percentages. All right. For percentages, what you need to know is when they say something is percentage, century, all right, or cent simply means 100. So it's like when I'm saying I'm working per hour for every 1 hour, what you get, all right? If I say 10 naira per hour, what it means is for 1 hour, I'll get 10 naira. So when I say 40 percentages or 40%, what it means is for every 100, what I'll get is 40. So you can write it in fractional form, and that's what makes it interesting, all right? So I can write 40%. This is the usual this thing you used to see, but what it means is 40 over 100, which you can cut to the lowest term because percentage is always represented by fraction. That is 4 over 10. That is, if I cut this one away, then we can still cut this one further, and then you have 2 over 5. So 2 over 5 is the same thing as 40%. The same way you can find 70%, you can find 85%, is always a way you can convert it to fraction. They can ask you to convert 40% to fraction. They can ask you to convert fraction to percentage. They can even ask you to convert decimals to percentages, all right? So these are simple way you get things done without having to belabor yourself over issues, all right? So please, I need you to know all this. Now, in the next 2 minutes, what is percentage increase? Find the increase, all right? My salary increased from 40,000 to 50,000. What is the percentage increase? Just find the difference. When something increased from 40 to 50, that's 10. Then the original value is the value that has been before, not the new value, because most people get it wrong. Increase, percentage increase simply is increase over original value. So your original value is 40,000. So you have to find 10,000 over 40,000 times 100, and then you get your value. All right. I'm only saying this because I know it is being recorded, but I need you to, I told you, pay attention to everything. It's not everything we can write down, and it's not. So as I talk now, I'm giving value. I've already given a question. So if you have not been attentive, you might not be able to get it. Let me come again. My salary increased from 40,000 to 50,000. So what is the increase? You need to first sort that out. 10,000. What is the original money I'm collecting before? 40,000. What is the percentage increase? The increase over original amount times 100. Simple. So 10,000 over 40,000 times 100. That is percentage increase. And the same way it goes for percentage decrease. And don't forget, I think one issue that students used to have is that when it is increased, they are wondering, should increase be plus, should decrease be minus? No. Whether it is percentage increase or percentage decrease, there is no minus. When you see minus, just ignore the minus aspect. All right, so I may have to next week come with more questions, and if you have some, come with some, let us talk about it, and then we are going to have everything fine. Please come with questions so that we can be solving questions in class. I will stop here for today because I don't want the Zoom meeting to end upon us. Thank you very much. I will be on standby. If you have any question in 1 minute, you can ask. So let me just, if you have any question, you can ask. This is the first slide where we started today. I gave question on working on these 2 questions as someone that has learned last week. You can get this done. And then we moved here, we tried to solve this. And then we also moved here, talking about conversion and then in decimals. And then we graduated to this point, decimal conversion of number basis. We moved down here and I gave some questions to practice. And then of course, the last one, we talk about percentage increase and percentage decrease. Thank you very much for the evening.